Yeah. Screen is visible.
Yes, sir.
Okay. Here is the problem. Following short circuit currents and voltages are obtained experimentally for a two-port network. Okay, here first one, with output port short circuited, it means what? Output port short circuit in the sense which quantity will be 0. In Y parameter, output port short circuited, or in any output port short circuit in the sense which parameter is 0, which voltage or which current will be 0. Tell me.
V2 is
Yes, V2 will be 0. No. Then with input port short circuited, which parameter is 0? See, with output port short circuited, V2 will be 0. With input port short circuited, V1 will be 0. Here, they given that the following, see here, following short circuit currents and voltages are obtained experimentally for a two-port network. With output port short circuited, they given for this, yes, I1 equals to 5 milliampere, I2 is equals to minus 0.3 milliampere, then V1 is equals to 25 volt. Then for input port short circuited, I1 is given as minus 5 milliampere, I2 plus 10 milliampere, V2 30 volt. Okay, we know by seeing the parameter given, we can directly V2 is equals to 0 in first case, equal to 0 in second case. Okay, now for first case, with output port short circuited, V2 equals to 0. Okay, now tell me the equations for Y parameter in terms of I or Y. I1, tell me, I1 equals to Y11 V1 plus, yes,
Y12,
Y12
1
V2,
V2,
then I2 equals to
Y21,
Y21 V1 plus
Y22,
Y22 V2. Okay, now V2 equal to 0. What will happen for these equations? Now V2 is 0 in first equation. Then Y11 is equals to I1 by V1.
V1,
Second equation, V2 equals to 0.
Y21 is equal
21
to
equals to
I2
I2
by
by
V1.
V1. Yes, V2 equals to 0. Now for the second case, V1 equals to 0. What will happen? V1 is 0 in this first.
Y12 is equal to
Y12
I1 by V2.
I1 by V2. This
Y22 is equal to I2 by V2.
Y22 equal to I2 by V2. V1 equals 0. Okay. Now already whatever the experimentally they got current and voltages, they have given that one. Just a substitute in Y11, Y21, Y12, Y22. Then tell me the values. This is your work now. Tell me the values for Y11, Y12, Y21, Y22. Yes, please.
Sir, Y11 is 0.2 milliamperes.
Yes, Y11 is 0.2 milliampere.
Millimho, sir, millimho.
Millimho. Yeah. Next, Y21.
0.33 millimho.
Y22 is
One.
yeah. Y22 is 0.33. Then
Sir, here then formula is wrong, no, sir.
which one?
For
See, for V2 equal to 0, I1 by V1.
Yeah.
Yes.
I was seeing Y21.
Okay, okay. We are just substituting.
The Y12 is 0.17.
Okay. Point
0.17 millimho.
I2 0.3 divided by 25. How much?
Sir, Y12 I'm saying.
How much?
0.17.
Okay. Minus or plus?
Plus, sir.
Next, Y21. Y12 is 5 divided by V2, 30. Okay, 0.17. Then Y21 is I2 minus 0.3 divided by V1, that is 25. That is minus 0.012.
Minus 0.12, sir, yeah.
0.12 milliohm.
Yes.
Y21 here minus 0.012 milli, and Y12 is 0.17 milli. Okay, this is my answer. Now, next problem will go. Which one? Yeah. Now, network is given like this. My two-port network is given like this. Okay, plus minus. This is V1, V2, I1, I2, 2 ohm, 2 ohm, 2 ohm. Here 3 I1. Okay, determine Y parameter of the two-port network given. Which type of source is this? Name it. Yes, anyone? Which type of source is this?
Current
Dependent current source.
Yes, CDCS, current dependent current source. Okay, now first step, what we need to do? First mark all the terminals. Okay, ports, that is 1, 1 dash, 2, 2 dash. Okay, now this point I'm going to mark it as A, this one as B. Okay, now I can write I1 is flowing in this 1 to A, I2 is flowing here 2 to B. Now I need to mark other branch currents because for Z parameters we have applied a loop analysis, that is KVL. Here for Y parameters we are applying KCL. So I1 is here. I need to mark other currents flowing in here, here and here. Okay, already CDCS is here. So I have marked all the branch currents flowing in the branches. Okay, now I am going to name it as I3, I4 and I5. Okay, first step, mark all the ports names 1 1 dash 2 2 dash. 1 1 dash is the input ports, 2 2 dash are the output ports, A B are the node points, A P. Next step, I am going to mark all the branch currents I3, I4, I5. Okay, now apply KCL. Apply KCL at node A. Yes, if you apply KCL at node A, what will happen? I1 is plus I1 minus I3 minus I4 is equals to how much? 20 or 10? Yes. KCL at node A, I1 minus I3 minus I4 equals to 10 or 20? Yes, guys?
0.
0.
0, sir.
Okay. Now, we know I1 equals to I3 plus I4. Okay. I3, how I am going to write? If this is the voltage at point A, see here, at node A, my voltage, node voltage is VA. At point B, my node voltage is VB. Here simply I can write VA VB. Okay. Now applying KCL at EA, I1 minus I3 minus I4 equals to 0. Then I1 equal to I3 plus I4. Here I3 I can write as higher potential to lower potential. I am going to assume this one as A to B, V minus 0 divided by 2, I3 for I3. Okay, then plus for I4, similarly tell me I4 VA
VM
minus VB
by 2.
divided by
2.
branch resistance 2. Okay, now after simplifying this one, see I1 equals to VA by 2 plus VA minus VB by 2. Okay, I'll get I1 is equals to V1 minus 0.5 V2. I call this as equation 1. Okay. I'm not doing anything extra here. I'm just applying KCL and finding the branch currents. Okay. Now apply KCL at node B. Apply KCL at node B. This point. Yeah, please. I4 is coming in. Yeah. Apply KCL at node B.
I4 plus I2 minus I5.
I4 plus I2. Yes, I4 plus I2. Yeah, then?
minus I5.
Yes, minus I5. One more current is there. Current dependent current source 3I1. See, this is leaving the node 3I1.
Minus 3.
Minus 3I1 is equals to 0. Don't confuse here. If the current dependent current source or dependent current source will be there, just write the whatever the current value is given, 3I1 is given. How the direction is as leaving, so minus 3I1. Now I2 equals to 3I1 minus I4 plus I5. Okay, we know I2 equal to 3I1 minus I4. Tell me for I4. This I4. VA minus VB divided by 2. Then I5 VB minus 0 by 2. Okay, after simplifying this one, see I2 equals to, I'll get 3I1 minus VA by 2 plus VB by 2 plus VB by 2. Okay, now I need to put I1 value in this equation. I1 equal to V1 minus 0.5 V2. Okay, now I'm going to insert this I1 in this I2. I2 equal to 3 V1 minus 0.5 V2. What is the simplification for this? VB by 2 plus VB by 2. VB, correct? Yes. I2 equal to 3 minus VA minus 0.5 VB minus VA by 2 plus VB by 2 plus VB by 2. I can write it as VB, right? Half plus half. Yes or no?
Yes, sir.
Now, I'll get final answer I2 is equals to 2.5 V1 minus 0.5 V2. I'll call this equation as 2. Now I have I1 equals to see VA and VB. VA minus 0.5 VB. This is equation 1. Compare this equation as Basic equation of y parameters. Then tell me y11, y12, y21, y22.
y11 1
y1,
1 sir.
yes. y12 is
Minus 0.5.
minus 0.5. y21 is
2.5 y22 0 minus 0.
yeah, y2 minus 0.5. y11, what is the unit of this admittance unit?
Mho.
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 So my y parameter matrix I can write like this. This is my final answer. Okay, now another example on y. Okay, now you guys need to solve this one. Okay, now this is the circuit given. Minus plus. Okay. 2 ohm, 3 ohm, 2V1. Okay, this is 1 ohm, V2, V1, plus minus, plus minus. This is given as I1, here is given as I2. First step. Determine y parameters for the network shown. First step is to mark all the nodes. 1, 1 dash, 2, 2 dash. Okay, A, B. Here at this node VA, at this node VB. Node voltage VA and VB. If this is my reference node, this is the which type of source is this? VDVS.
Voltage dependent voltage source.
Yes,
VDVS.
voltage dependent voltage source. Okay, now next step, mark the branch currents. Okay, here, okay, here, here, here. Yes, I3, I4 and I5. Next step, apply KCL at node A. Yes, tell me. Apply KCL at node A, this node. I1 minus I3,
Minus I.
I4 equals to 0. Yes. Now I can write I1 equal to I3 plus I4. Now I1 equal to I3. I3 is nothing but
VA minus 0 by 2.
VA minus 0 by 2 plus I4. See here. This branch, AB branch.
VA plus 2V1 minus VB
VA plus 2V1 minus V2.
minus VB by VB sir
Sorry, yeah, sorry. VB by
3.
by 3. Okay.
3
Here,
3
Yeah, 3 only. This is 3. VA minus to plus 2V1 minus VB divided by 3. Okay, simplify. I'll get I1 is equals to 1 minute. I1 I'll get as I1 is equals to 1.5U V1, then 0.33 V2. Call this equation as 1 VA and VB. I1 I'll get as 0.5 VA minus 0.33 VB. Then apply KCL at node B. Apply KCL at node B. Yes, apply KCL at node B. I4, then minus I5 plus
I2 plus
I2.
I4 minus I5 is 0.
Yes. Now I can write I2 equals to I5 minus
I4.
I4. Now tell me for I5. This I5. VB divided by,
minus 0 by 1.
yes, VB minus 0 by 1, then minus I4 here, minus of
VB
V1
minus
V,
2V1
no,
minus VA by
VA plus 2V1 minus VB here, VA plus 2V1 minus VB, because minus here, divided by 3. After simplifying,
So we can
I'll get
directly take it as from node B, no sir, like VB minus.
yeah, that also fine. VB minus of
VA plus 2V1.
yeah VA plus 2V1. This is also fine. Okay. After simplifying, I'll get I2 as minus VA plus 1.33 VB. Equation as 2. Now compare I1 and I2, that is equation 1 and equation 2 with the basic equations. I'll get Y11.
Sir, you left out 2V1. 0.66 minus 0.66 V1.
Which one?
That term, so 2V1 by 3.
In which equation you are talking about? Which
So
one
if you
minus?
solving the equation to
Second
solve.
equation, sir. 1.33 VB minus 0.66 V1.
See, after simplifying, I'll get I2 minus VA plus 1.33 VB.
Sir, 2V1, sir.
Yeah. That only after simplifying. This is not, say, what I'm going to say. Here, this V1 is the right. Here VA is equals to V1. Okay. This
Yes,
voltage
sir.
source
Then it
depend
is.
upon this node voltage. Here notation have marked it is wrong. Okay, correct only. VA is equals to V1. then I'll get as I2 equal to minus means V1 plus 1.33 V2. If we are going to take VB equal to V2. Here VA minus VA plus 1.33 VB. This is equation number 2. Okay. Now Y11 is 1.5. Y12 is minus 0.33. Y21 is minus 1. Y22 is 1.33 plus 1.33. So my Y matrix, Y parameter matrix is 1.5 minus 0.33 minus 1, 1.33. Okay. And please don't confuse here. See, whenever we are writing the equation for this node, okay, VB, this is VB minus of this, okay, divided by, see here this is wrong. Check this out, please, because if I am having this circuit, okay, this is somewhat my circuit, VA, VB. Okay, for writing this one I'll call as R1, R2, R3. For writing this current equation, I1, I2, I3, I4, I5. Okay, this is a simplified circuit where if I want to write I3 is equals to, how I am going to write, Arjun? If I take this one as a reference node,
Sir,
I3 is
for
equals
node
to,
A, you are taking.
yeah, node A.
Yeah, I3 will be I1 is equal to I3 plus I4. So I3 will be I1 minus I4.
Yeah, that's okay. Tell me the formula for this branch current.
Sir, VA
I3
minus
is
0 by
A
R1.
minus 0 by R1.
VA minus 0 by
0 by
R1.
R1. Okay. For
Yes, sir.
I4,
I4, it will be VA minus VB divided by R2.
okay. For if I am writing the equation, okay, I am writing the equation for VB. The sign will change like this. Okay, VB. This is I5.
Yes, sir.
First I5. First I5. That is VB minus 0 divided by R3. Then here also I have to write I4, right? It's coming inside. Here
Yes,
for
sir.
VA
So
is going outside. So VB minus VA divided by R2. Same here, what we did by considering B point plus this 2 plus 2 minus that instead of minus 2V1, okay, minus VA. It will be like this. If you know, everyone knows this one, but for don't confuse. Otherwise,
no, sir,
every answer.
why I did that is because here we can take this as minus I4, right? So, like in
Yes,
that
yes.
equation, we had it as minus I4. So instead of like writing I4 then taking minus, we can directly take minus I4 by taking from node B. That's what I am meant.
Yes, correct. 2V1 minus VB divided by 3. If I'm writing for B, I4 equals to VB, okay, minus of minus 2V1 minus VA divided by 3. This is correct, right? If I write like this for A and for B. Yes?
No, sir. It will be that in between minus. It won't come, no, sir. Like we'll be applying sort of like KVL, no, sir. So it will be VB minus 2V1 directly. Like we won't require that additional minus in between.
See here, for first A node, I4 equals to VA plus of 2V1 minus of VB.
Yes.
Correct? Current is leaving the node.
Yeah.
Means N. So minus VB. Correct?
Yes, sir. Yeah.
Here for writing the equation for this B, VB minus of, okay, this is
No,
plus.
sir. Like
Yeah,
yeah,
this is
that
plus.
will be a plus.
Yeah,
That's all.
this is plus. VB plus minus of 2V1, then minus of VA.
Yeah, that is
Now
correct.
it's correct. Now it's correct. Yeah. Okay. We'll stop here.